All right, so hopefully you've been following along and you took notes on number 5 and then tried number 6 on your own. So that was a quadratic equation, but it just had a variable that just needed to be squared. And same thing for number 6. So for number 7, we have a variable outside the radical, but also a number. So this is going to be the most complicated type of problem that we get. And number 8 is similar. All right, so just quick reminder of the steps. If you haven't already written those down, you're going to want to pause this video and write down those steps. All right, moving on. So for number 7, first I want to make sure that my radical is isolated. In this case, it's not, because on the same side of the equation, I have a negative x that is not inside the radical. So I need to get rid of that first. I'm going to add an x to both sides. That's going to give me x plus 1 equals square root of 37 minus 3x. Now this radical is isolated. But when I raise this to the second power, because I have a square root, I had to do that over here too. But notice, this is a binomial being raised to the second power. That means I'm actually going to need to do an area model there. So just keep that in mind for a minute. On the right-hand side, I'm just going to have 37 minus 3x. But for the left-hand side, let's look at this. I've got x plus 1 times x plus 1. It is not just x squared plus 1 squared. It's not that simple because you have other combinations of terms. The x multiplies by the x and gives you an x squared. And the 1 multiplies by the 1 and gives you a 1. But you also have x times 1 and 1 times x. Each of those give you a 1x. So I have x squared plus 1x plus 1x plus 1. But then we can combine these. We have 1x plus 1x. That's 2x. So I'm going to have x squared plus 2x plus 1. All right, this is a quadratic equation, but it's not too bad. I need to look for where my quadratic is, and I want to move everything towards that. So I'm going to move my 3x over. It's negative, so I'm going to add 3x to both sides. That will cancel. And this is a positive 37, so I want to subtract it from both sides. So that is going to give me x squared plus 2 plus 3, so 5x. Positive 1, negative 37 is negative 36 equals 0. All right, so I'm looking for numbers that multiply to give me negative 36 and add to give me 5. All right, so you might think 6, negative 6. Those multiply correctly, but they don't add correctly. You might think, oh, I don't know, 12, negative 3. That doesn't work either, because when you add those, you get 9. And eventually, you might have to try a few pairs, but eventually you might come up with 9 and negative 4. That is the correct pair. 9 times negative 4 is negative 36, and 9 plus negative 4 gives you 5, which means we have x plus 9 and x minus 4 equals 0. We have to solve each of those individually. So x plus 9 equals 0. I'm going to subtract 9 and I get x equals negative 9. And I also have x minus 4 equals 0. I'm going to add 4 and that gives me x equals positive 4. All right. So we've got two solutions. We're going to have to test them out. So I've, again, run out of room, so I'm going to do it on a separate sheet of paper. My original equation, I go back to the very beginning for this. 1 equals negative x plus the square root of 37 minus 3x. Now I have two solutions, so I have to do this twice. I'll go ahead and get that set up. 1 equals negative x plus square root 37 minus 3x. All right, I'm going to put in -9 over here. And I'm going to put in 4 here. In both cases, this is a question. We're testing whether this is true or not. So I'll try the -9 first. I've got 1 equals negative of negative is a +9 plus, all right, this is 37. Negative times a negative is +27. You can already see them. I'm probably going to have a problem. So I have 1 equals 9 plus, let's see, that's square root of 64. Square root of 64 is 8. So I have 1 equals 9 plus 8. Well, no. 9 plus 8 is 17. Those are not equal. So this is extraneous. And I'm going to go back on my paper and cross off -9. Then I'm going to try it with a 4 in place of x. So I have 1 equals, I can drop the parentheses, -4 plus, all right, now I have square root of 37 minus 12. All right, 37 minus 12 is 25. So that's 1 equals -4 plus square root of 25. Square root of 25 is 5. So I have 1 equals -4 plus 5. Is that a true statement? Yes. That gives me 1 equals 1, which is true. So I will keep this answer because it led to a true statement. All right, so if you've been following along the videos for number 5 and number 7, you should now try number 6 and number 8. Remember, on number 8, you're going to need to subtract 3 first to isolate this radical. So you'll have n minus 3 equals a radical.